10.2, example 1. In this example, we're going to look at finding the magnitude and direction of a vector. So the first thing I like to do is I like to go ahead and take a second to draw out this vector. So the way we draw this vector is we go ahead and plot the point -1, 3, and then we start at the origin, and then draw an arrow going to that point. So what I also like to do is take a second and draw the components. So it's radical 3 up and -1 across, and then theta starts at the positive x-axis and is the angle to that vector. So what we want to do is find the magnitude and direction. So in order to find the magnitude, that is the absolute value like this. And that's just going to be the square root of -1 squared plus radical 3 squared, which is going to be the square root of 1 plus 3, square root of 4, which is 2. So the magnitude of that vector is 2. And now we just need to find the direction. So to find the direction, if we have the x and y components, we can use tangent, because tangent of theta is equal to y over x, so it's going to be radical 3 over -1. So we need to figure out where does tangent of theta equal negative radical 3. And so if we use that, we know that theta is equal to negative pi over 3. But remember that theta cannot be negative. So what you want to do is go ahead and add a pi, because the period of tangent is pi. So negative pi over 3 plus pi is 2 pi over 3. So I get that the magnitude is 2, and the direction of the vector is 2 pi over 3. Alright, now on your own, I want you to go ahead and determine the magnitude of the vector 3, 3. Alright, so let's go ahead and give this a try. So we have this vector is going to go ahead and look like this, because we're going to the point 3, 3 and starting at the origin. So the magnitude is going to be the square root of 3 squared plus 3 squared, which is the square root of 18, which is going to be 3 radical 2. And the direction, I'm going to do tangent of theta is equal to 3 over 3. So tangent of theta is equal to 1. So theta is pi over